Alright, welcome back. We're still talking lesson 2, basic derivative rules. And rates of change. In the last two videos, we talked about the constant rule, the power rule, and the constant multiple rule, and did some examples on them. Today, we're going to talk about our next theorem, Theorem 2.5. And this is going to be the sum and difference rules. So what we're going to say is the sum or difference of two differentiable functions. We'll call them f and g. Is itself differentiable. Moreover, the derivative of f plus g, or even f minus g, is the sum or difference of the derivatives of f and g. Meaning, if we're finding the derivative of f of x plus g of x, it's just going to be equal to f prime plus g prime. This here is the sum rule. Likewise, if we're looking for the derivative of f of x minus g of x, it's going to equal f prime minus g prime. This is the difference rule. So let's look at an example of how we would actually use the sum and difference rules. So this is going to be example 7. All we're going to do is find the derivative. We're going to have 3 parts to this example, an A, a B, and a C. Part A, we're going to find the derivative of the function f of x equals x cubed minus 4x plus 5. Now we're going to apply the sum and difference rules and possibly some power rules and other things we've learned so far. When we're looking at that sum and difference rule, when we're looking at this problem, we're really just splitting up all the terms and we're finding the derivative of each separate term. So when we're finding the derivative of this function, when we're finding f prime, we're going to first find the derivative of x cubed. And based off the power rule from 2 videos ago, the derivative of x cubed is going to just be 3x squared. Now we're just going to keep that minus. We're going to bring it through. We're going to look at the derivative of 4x. We can look at that as a constant multiple rule, where we take 4 and we multiply it by the derivative of x. Well, the derivative of x is just 1, so it's 4 times 1. So it's just going to be 4. We can bring that plus through, and from our first video in this basic differentiation rules, 5, that's a constant function. Well, the derivative of a constant is 0. So let's clean this up a little bit. Our derivative is just going to be 3x squared minus 4, because if we added the 0 to it, it's just going to be 0. And we've actually finished finding the derivative of x cubed minus 4x plus 5. Let's try it again. We're going to look at part B. Our function is going to be g of x is going to be equal to negative x to the 4th over 2 plus 3x to the 3 minus 2x. So again, with this sum or difference rule, all we're doing is we're looking at each term separately and finding the derivative of it, and then just putting it back together. So let's find the derivative of that first term, negative x to the 4th over 2. Well, we can rewrite that as negative 1/2 times x to the 4th. Then we're going to just find the x to the 4th, the derivative of that. So when we're finding g prime, we're going to have negative 1/2 times 4x to the 3. And then we have a plus. We're now going to find the derivative of 3x cubed. Well, based off of that constant multiple rule and the product rule, we can write that as 3 times 3x squared. And I need to write the next term on the next line. I've run out of space. Minus, well, the derivative of 2x is just going to be 2. So we're almost done. We're going to clean this up a bit. We're going to go negative 1/2 times 4. That's going to give us negative 2x cubed. And then we're going to go 3 times 3x squared. That's going to give us a plus 9x squared. And then we just have this minus 2 we have to put at the end. So the derivative of negative x to the 4th over 2 plus 3x to the 3rd minus 2x is just negative 2x to the 3 plus 9x to the 2 minus 2. I've got one more example I want to look at with example 7. So 7c. We're going to look at the function y equals 3x squared minus x plus 1 all over x. Now, what I'm going to do is I'm going to rewrite this, and it's going to look kind of funny because I'm going to take each term and I'm going to put it over x. So we're going to have 3x squared over x minus x over x plus 1 over x. And then I'm going to simplify the terms I can simplify. So 3x squared over x, that actually just simplifies to 3x. Minus, well, x over x, anything divided by itself is 1 plus 1 over x. We can't simplify that. In fact, we could still rewrite that, though. So let's do that. Let's rewrite the 1 over x as x to the power of negative 1. Now we can find the derivative. We're going to find y prime. So we're going to find the derivative first of each separate term. And if it helps to separate the terms, go ahead. Put a line through it. Separate them out. So derivative of 3x. That's just 3. Minus the derivative of 1. That's a constant function, so the derivative is just 0. Plus the derivative of x to the negative 1. We bring negative 1 out front, write x, and then we reduce the power by 1. So we're going to make it to the negative 2. Which means we're going to have 3 minus 1 over x squared. And I'm actually fine with you leaving it that way. If you want to get a little bit more technical, we could and really should go a little farther, but like I said, this is acceptable. If we did go farther, though, we would want to find the common denominator and actually subtract these two fractions. And in this case, a common denominator would be x squared. So we could rewrite it as 3x squared over x squared minus 1 over x squared, which really means we just have 3x squared minus 1 over x squared. So I would take that first box or the second box as acceptable answers to this problem. Now for our last theorem in Lesson 2.2. We might not get all of our examples in this video, but it's our last theorem. So this is theorem 2.6, which is the derivatives of sine and cosine functions, which are actually pretty simple. If we have y equals sine x, then the derivative y prime is just going to equal cosine x. And then if we have the function y equals cosine x, the derivative of that function, y prime, it's going to be negative sine x. Now, I don't really have a reason to show you why it's that. You could check page 115 in your book to the proof of why these work. I would just suggest memorizing this one. So let's look at an example. We'll call it example 8. We're just going to find the derivative. And I'm going to have 4 fairly short ones to show you here. So 8, we'll call it 8a. We're going to have y equals 2 sine x. We want to find the derivative. Y prime. Well, that is just a constant multiple. So we know that's going to be brought through to our derivative. We're going to have 2 times the derivative of sine x. And the derivative of sine x, according to theorem 2.6, is cosine x. So y prime is going to be 2 cosine x. That's it. 8b. Let's look at that one. We're going to have y equals sine x over 2, which really means we have 1/2 sine x. So let's find the derivative of that. Well, we know that 1/2, or even the division by 2, since that's what 1/2 is, that's a constant multiple. So that's going to come through. So we just have to find the derivative of sine x. Well, the derivative of sine x is cosine x. So the derivative of sine x over 2, cosine x over 2. And we're done with that one. Let's look at 2 more. So 8c, we're going to have y equal to x plus the cosine of x. So this example does incorporate a few of the other rules we've talked about. We've got a sum rule here, and we've got one of the sine cosine functions. So let's start by first breaking this up. When we find the derivative, we're going to find the derivative of each term separately. So y prime is going to equal the derivative of x, that's just 1. And according to theorem 2.6, the derivative of cosine x is negative sine x. So we're going to have 1 plus negative sine x, which we can actually just write as 1 minus sine x. And we've found the derivative of x plus cosine x. Let's look at the last example I have of sine and cosine derivatives. It's going to be 8d. We're going to have y equal cosine x minus pi over 3 sine x. So again, this has a lot of what we've been talking about, but it does have that sum difference rule in there. So we're going to first split it, and we're going to now find y prime of each term separately first. According to theorem 2.6, derivative of cosine x, negative sine x. So that first term, we're good. Minus pi over 3 sine x. Well, that pi over 3, that's just a constant multiple, so that's going to come straight down. And according to theorem 2.6, the derivative of sine x is cosine x. Which means we actually just finished this one. The derivative is going to be negative sine x minus pi over 3 cosine x. We're actually going to call it good in this video, but we do have 2 more examples left for this lesson. They'll be in a 4th installment of 2.2.